Now we discuss how we can add the matrices or how we can multiply it. In multiplication, first we take with the scalar and then matrix multiplication. Addition of matrices is not difficult. Number one, they must be of the same size, and we add entry wise, then we can add it. So we have the addition of the matrices. Addition of matrices. Number one, same size. Number two, we add entry wise. I take an example. I have matrix A. My matrix A is 2, 1, 3, 3, 2, 4. This is matrix A. I want to add a matrix B. No, this size of matrix is 2 by 3. So we can add only a matrix which is 2 by 3. So I take the matrix B as minus 1, 2, minus 1. We're having here minus 2, 1, and 0. So I want to add it. I write here A plus B. So my addition is entry wise. So A11, B11, we're having 2 minus 1. A12, B12, 1 plus 2. A13, B13, 3 minus 1. Then A21, B21, A22, B22, A23, B23. We add it and we can get here the result is equal to, we're having here 1, we get here 3, we get here 2, we get here 1, we get here 3, we get here 4. This matrix of the same size. We're having two matrices. This is 2 by 3, this is 2 by 3, we add it. And we can have, addition is, we get the corresponding entry in addition, and we can see, we get the result as 1. This is 2 minus 1. 2 minus 1 is 1, 1 plus 2 is 3, 3 minus 1 is 2. Then 3 minus 2 is 1, 2 plus 1 is 3, and then here 4 plus 0 is 4. Now we can see one more property, that if we add B plus A, so we add here B plus A, so they will remain the same. We can add it, we can add B, this is minus 1 plus 2, we have 2 plus 1, 2 plus 1, we are having minus 1 plus 3, minus 1 plus 3, then we are having 2 minus 2 plus 3, then we have 1 plus 2, and we get here 0 plus 4. So you can see here the result we are going to get it here is equal to, we get here 1, we get here 3, we get here 2, we get here 1, we get here 3, we get here 4. So we look on this result. I say this is my number 1, and this here is number 2. So look on number 1 and number 2, we can say this implies that where A plus B is equal to B plus A. So we say they can commute. We can change them and we can commute them, and the result is the same. So we say the commutative law holds for this one. So A plus B is equal to B plus A. Then we go to the next property, the scalar multiplication. Scalar multiplication. As I told you, we have two types of multiplications. We'll discuss after this one, the matrix multiplication. Scalar multiplication is, we have scalar is any number, multiply with the matrix. For example, I have matrix A. My matrix A is 3, 2, 1, minus 2, 4, 7, and I have here 1, 3, and 5. So I take any scalar. I say, let my scalar is, my K is scalar is 5. K is equal to 5. I want to write here, my K is equal to 5. I want to write Ka. K is mean 5A. So this is equal to 5 into my matrix A. My matrix A is 3, 2, 1, minus 2, 4, and 7, 1, 3, and 5. Now when I multiply by the scalar, so each entry of the matrix is being multiplied by the scalar. So this means each entry will multiply by 5. So multiply 5 by 3, 5 by 2, 5 by 1, 5 by minus 2, 5 by 4, 5 by 7, 5 by 1, 5 by 3, and 5 by 5. So I get here my matrix as 15, 10, 5, we have minus 10, we have 20, we have 35, we're having here 5, we have 15, we have 25. It's a very important property. Don't forget it. I take a note here. For example, I have matrix A. My matrix A is 2, 4, 6, and 8. Now, if I want to take common from this matrix, so this common will be from each entry we have to take common. I can write here my A is equal to, I take 2 common, I get here 1, I get here 2, I get here 3, I get here 4. Opposite this one, if I say I want to multiply by 2, it means each entry is multiplied by 2 and get this matrix. So we take common from each of the entry, we multiply each of the entry with this one. This is known as our scalar multiplication. Very important concept. We are going to use this one in our different problems. So again, I will repeat it. Scalar multiplication means k is any number. It can be any function. We can take x. So for example, I can take here k is equal to x. Then I want to write this is k a is equal to, get here 3x, 2x, x. From this matrix, we are going to apply this on this matrix here. Then we multiply here by x, we get here minus 2x, we get here 4x, we get here 7x, we get here x, we get here 3x, we get here 5x. So we multiply each entry by x. When I take k is equal to x, so each entry is multiplied by x. Or I can take common from this one. We can take x common from each of the entries. So this is the idea in scalar multiplication.